Hello and welcome to the eTech podcast with me, your host, Ryan Maughan. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts, as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. And for today's episode, I'm joined by Jim Castelaz, who is the founder and CEO of a company called Arcticar. And he's joined us today to talk some more about what he's up to right now. But Jim's actually someone I've known for a long time, and his history is absolutely fascinating. So welcome to the show, Jim. It's going to be really interesting to learn some more about you.
Thanks so much for having me, Ryan. I'm looking forward to it.
Great. Now, can you start by telling us a bit more about yourself, whereabouts are you based, and how you got involved in engineering in the first place?
Yeah, sure. So I live in the San Francisco Bay Area, little island town of Alameda. I live here with my wife and 6 kids. And I've been in the Bay Area since graduate school, Stanford University. Before that, I was in Southern California, but I'm not a California native like people have been doing for decades. I came to California looking for gold, more of the IT engineering and entrepreneurial version, but it's a state with a rich history of gold rushes going back, almost 200 years at this point. So I grew up actually in rural East Tennessee, up in the Smoky Mountains. We were there. My dad got a job there as a physics professor, astrophysics. So he's an astronomer.
Cool.
Yeah. How he landed at East Tennessee State University was kind of an interesting journey, but that was where I ended up growing up. And he inspired a lot of my love of science and engineering. So even from a young age, I would help him when he was calibrating instruments for telescopes and things like that, sometimes in our driveway, which was a lot of fun. And always kind of really liked the instrumentation and the electrical systems. And so was able to have, do fun projects as a kid in that regard, mostly facilitated by my dad, electromagnets or little go-karts, or one time tried to build a pontoon boat, with an electric motor. They all seem to have electric something.
Okay, cool.
I even have a poster as a kid where it was like, what do you want to do when you grow up? And it says, I want to build electric cars. So
okay.
I've never built electric cars, but I've built electric trucks, which I feel like is pretty close. So,
yeah, you went for something a bit bigger.
Yeah, I guess so. I guess as I got older, I thought, maybe want like a bigger medium duty truck. And actually now going even bigger with Arcticar, full size 53-foot trailers. Even a bit bigger than those medium duty trucks. So I don't know what I'm gonna build next. I'll have to go to mining equipment or something, or maybe planes. There aren't a lot of trains, maybe. Yeah.
And so you studied? Did you study electronics engineering when you went to university?
So I ended up going to Harvey Mudd College in Southern California. My uncle lived in California and said, you should check out this small engineering school. And I went and loved it. I didn't know anything about it in advance, but it was actually all general engineering. So I did a lot of the electrical engineering classes, but I also did some mechanical and thermal and chemical and all types of engineering and more broadly, even beyond engineering, even got to take a political philosophy class, which was pretty fascinating stuff. Got exposure to some philosophy, which has continued to follow me through life. It was general engineering, but I was always a Sparky at heart. I always loved the electrical bit. And so then I moved up to the Bay Area for graduate school at Stanford University to study electrical engineering. Yeah.
Okay. That's really cool. Yeah, there's a few universities in the UK who do offer that kind of general engineering rather than specializing in the at the undergraduate level. So it's a sound approach. It gives you a bit of an exposure to across all of the disciplines, so you can speak a bit to everyone.
Yeah, I think it was good for an undergraduate like to have that broad exposure. And honestly, so many engineering challenges are integrated, right? Like I think it's rare to find any type of real world engineering where you're not
Yeah.
hitting two, three, four, all of the engineering disciplines. So
I was just reading an article this morning about the multi-physics aspect of electric motor design. So I think that probably pretty much covers all of your bases.
yeah, I hit everything with that. Yeah.
Yeah, very good. So then after you graduated, was it sort of straight into electric vehicles at that point, or did you do something else first?
Well, I have to correct you a little bit. I actually dropped out, so I
Okay.
didn't quite make it. But to be fair, that was from a PhD program. So got my undergraduate degree, went up for my what I thought would be my PhD. And like my first semester at Stanford, I got bit by the entrepreneurship bug. It's like there's a very virulent strain of it at Stanford University, I found. And so from my beginning kind of graduate work there, I was interested in like entrepreneurship, starting a company. What does that mean? Why? What does it look like? And I think I was drawn to it really initially, just like the idea of being able to do something new and pursue an idea that maybe no one was doing. And I think it takes like a little bit of naive optimism to be an entrepreneur, right? You definitely have to be an optimist. And then there's like, it turns out it's all really hard, but if you like see the world through rose-colored glasses with some optimism, and you're maybe like happily and naive about some of the challenges, then you can dive right in, and if you have some grit, you might actually get through to the other side. And so I ended up getting a master's degree and then taking a leave of absence from my PhD program. I was studying power electronics, micro electromechanical systems, some interesting research looking at like enhancing the efficiency of solar cells and doing power switching, all using MEMS structures. And then I started out of that, I just went straight into starting Motiv. So I mean, maybe I've never had like a real job, I guess. I don't know. It's funny trying to write a resume as an entrepreneur. Like, what do I have transferable skills or not? But it's been a fun and interesting journey, and I've learned certainly a lot along the way. So I started Motiv then, like straight after my master's degree at Stanford, and began Motiv in 2009, essentially. Yeah.
Okay, good. I was just about to say, when was that? So 2009 is pretty early on. Obviously, people listening, we haven't explicitly said what Motiv does yet, but they'll have got the general vibe that it was something to do with electric vehicles. So that's pretty early on in the kind of trajectory of electric vehicles. What was the thing that made you think, I want to go and build electric trucks?
I was. So, circa 2009, Tesla was not far beyond a group of solar car racer students at Stanford University, right? It was even pre Elon Musk, with Martin and Mark and Ian Wright and others, and so I kind of knew of them, knew a little bit there. I wasn't on the solar car team or anything like that, but I was kind of aware that was going on, and thought that was a pretty neat approach. I cribbed two insights actually from the early Tesla team that I thought were like just really great insights. One was the shift in complexity when vehicles electrify. Mechanically, they get so much simpler. There's not much mechanical complexity, but a lot of that complexity shifts into electrical and software complexity, specifically software complexity. And so that struck me as that would be an interesting and fun challenge for both existing companies and opportunity for new companies. And so I was kind of thinking through that, and then I worked with just a team at a class, and my class team at Stanford was looking at electric motorcycles, and we were thinking like, could you apply Tesla's? One of their initial business premise was like people aren't used to paying for range in a vehicle, right? You buy like a gasoline vehicle, get as much range as you want. This is all early EV days. We don't even think too much about this anymore, but in the day, this is a big deal. people don't pay for range, but range is really expensive because batteries are really expensive, right? This was the conundrum of early EVs. And Tesla's solution was, well, with electric cars, you actually get really great performance for almost not a lot of incremental dollars of cost. So people are willing to pay for performance. So if we deliver high performance, they'll pay for that, and we can use that value that they're getting to cover the cost of the battery system. So we'll end up giving them the range, the expensive part, along with that performance. And we thought, well, could we do that in motorcycles? And it's possible. Motorcycles are actually pretty tough, though, right? The power to weight ratio of a motorcycle is just insanely high. One of the highest of any machines that we deal with. So it was a bit of a challenge. The other thing that I learned with motorcycles is they don't use that much fuel, like gasoline, right? They just, over their lifetime, you don't put that many gallons of gas in the tank of a motorcycle. So that led me to trucks, because they're kind of the opposite. Over the lifetime of a truck, most of the cost of the truck is right into that fuel tank. And so I thought, well, maybe there's an economic case to be made to electrify trucks. And I think that continues to be true. Maybe not as fast, like that market didn't develop as fast as I thought it might in 2009, but for a lot of interesting reasons, really. We could talk more about that, but yeah, I think the initial premise was like, let's electrify these trucks because we can offset a ton of fuel.
Yeah, okay. So that's a sort of a more almost a more noble thing than, I mean, I think electric cars are great, and I was talking to somebody the other day saying, it's mad how much it's kind of normalized. You look like a family SUV doing 0 to 60 or 0 to 100 kilometers an hour in like 4 seconds is normal now, which, when I was growing up, a car that was like 0 to 60 in kind of 6 or 7 seconds was considered to be very fast. So what electrification has done to our expectations of performance, particularly in terms of that standing acceleration, is it's kind of cool in some hands, but then in other ways it's like not so cool. But it's definitely fun. You can't deny that. Used appropriately and responsibly, of course. But the business case that you were looking at was more sort of commercial, something that uses a lot of fuel. Can we help them save fuel, and looking at that kind of footprint, right?
Yeah, I say much less sexy business model to electrify trucks, but I think there are a lot of reasons that it makes sense. The economics. I had a rewarding moment early on in the history of Motiv was a driver who told me, speaking about an early prototype electric truck, this truck has changed my life. Right? If you look at the work environment of people that work around heavy duty trucks, right? It's not great working around diesel trucks all day. I mean, people joke about how much they like the smell of diesel, right? Which, okay, but it is actually giving you cancer too. So, right, and probably making you deaf long term. So, like, can we make the work environment of people that work around these trucks better? And going electric, man, when you're working all day on an electric truck, it's just so much like your office is your truck, and it's such a better experience, right? There's no noise, there's no heat from the engine, there's no vibration from the engine, there's no carcinogenic fumes. So I think I'm probably just as proud for what Motiv accomplished in making the lives of drivers better as for the fuel savings are a big deal too. Like, I think let's get the carbon and pollutants out of the air, create some energy independence. I think it's all good. What I like about electric vehicles, up until at least a few years ago, like, everybody was aligned around all the benefits. It wasn't like a political thing. It was like, this gives us energy independence. It's a better work environment. It's cleaner. Like, who doesn't like this? Right? I think maybe it could, then you get pushing into like, well, how much do we push people to like change their behaviors? And, even if they maybe arrive at somewhere better at the end, I think that those are tougher questions.
Yeah, business tends to come in around, a lot of companies will say they'll do things for altruistic reasons, but at the end of the day, their business exists to make money. And if you can do something that helps them make more money, then they'll tend to go for it. And I guess in the early days with electric trucks, it took a company had to be curious and have sort of it wasn't a straightforward business case, let's say, with the early trucks, the significant cost increase and having to think really hard about how they use them in practice compared to a normal truck. You think?
Yeah, well, I mean, yeah, I think you needed companies that wanted to lead in some way, right? Because it wasn't easy. It wasn't like, hey, just buy these electric trucks, plug them in as a replacement of your diesel trucks, and you won't need to change anything, right? It was more expensive. They needed to like figure out charging. In some cases, they had payload or range issues, especially the early trucks. But then I look at some fleets, some companies. Really, it was, in a lot of cases, it was probably like a large private company that empowered their fleet leadership to pursue a vision. Right? I think of like our early customers, like Ameripride Linens, that was acquired by Aramark, who changed their name to Vestas. Right? It's like some of these linen companies, they were empowered. They said, hey, we're in the business of delivering tablecloths and uniforms and all of that. And these are all reusable products. We pick them up, we launder them, we send them back out, right? Like we actually have a business model around sustainability, and we want our fleet to reflect that. And then so you got real leadership, I think, coming out there in the early days, and frankly, some really great leadership from some government agencies who were smart about taking like greenhouse gas reduction funds that they had and allocating those towards some interesting pilots, like California Air Resources Board, California Energy Commission. I think before these things got so controversial, it was pretty well aligned to use funds that were meant for this to like create some really interesting pilot projects, and push the needle forward. And the industry needed that because the whole supply chain had to be built, right? That was one of the most fun parts. So Motiv Electric Trucks builds medium-duty electric trucks, one of the market leaders of that now. I started the company in 2009, just to recap for people who don't know it. It's still around building medium-duty trucks. I left it earlier this year, and we'll talk more about that. But I think the value proposition is pretty strong, but it's taken 15 years, and we're still building that supply chain for battery packs. And a lot of it is still in China. Right. And I think the market's moving forward, but it takes a long time to build that kind of a market.
It's always, one thing actually, just to sort of get out and maybe talk about a little bit, but America is special, as we you're special anyway, you guys, but particularly from a trucking standpoint. The trucks, heavy duty and medium duty trucks that roll on the roads in the US are quite different to what we might have over here in Europe, certainly. And the trucks that you were building at Motiv, the traditional industry that stands behind those kind of products, I think it's fair to say in 2009, traditional would be the right word. Like they are very different to kind of delivery vans that you would see on the roads in Europe. Quite sort of basic technology involved, chassis coming from big manufacturers, and then bodybuilding coming from lots of quite a diverse, smaller range of companies, lots of customization and sort of bespoking and stuff like that. So it's a pretty special industry in the US, actually, that I'm not sure that it's like that anywhere else in the world. It's normally more about sort of high volume standard products than the sort of special delivery vehicles. Do you think that kind of helped you initially, or was it a hindrance that actually you go from one fleet to another and they've got their own sort of particular preferences on the kind of brakes that they fit to the truck, or the axle that they fit, or we only buy this seat, and it's so customized for every different fleet. Was that a good thing or a bad thing in the early days?
It's a great question. It is a fascinating market, somewhat unique to the US, that like a truck, or these delivery trucks, for example, get built in so many stages, right? You have like, and as it gets built, it gets more and more customized. I think it, and there are a few reasons for that. You also have customers with a lot of buying power that are buying a lot of vehicles. And so with that buying power, they can specify a lot of what they want. Look at like the United States Postal Service awarding a $5 billion contract to Oshkosh, right?
Yeah.
They're like funding the entire vehicle development and everything because they buy enough of them. So it's a fascinating space in that regard. I think it gave it gave the whole electrification industry and Motiv an easy entry point into lower volume production, which is both good and bad. I think it's hard in the early days of a market to just say we're going to invest, $1 billion and bring a really high volume product to market. There are, if the market's big enough, you can maybe do that. I think Tesla kind of got there through some fits and starts, right? But even Tesla had a bit of a jump start in the early days working with Lotus, right? So so figuring out how to prime the pump and get to the point, and it's not just about justifying the investment. It's really about knowing what to build, I think, right? You like need these design iterations as a market evolves to get to the right product. You're never going to build the right thing at first. So, in Motiv's case, I think it was good. We partnered with Ford and we could use some Ford chassis and we could focus our innovation around the powertrain and work and iterate on that to deliver exactly what customers wanted, and work with some of these leading customers. And it's like reasonable to think if you get one or two of these large fleets and you can work with them closely, they alone can command enough volume to justify the investment and the product development, right? And so I think it's an interesting way to like push technology forward, this fleet market. It actually allows for innovation, I think, because it's so fragmented.
Interesting. And in Europe, I think there were companies in the early days, because we're effectively a panel van market in Europe, so that sort of medium duty delivery truck doesn't really exist. It's a Sprinter van or a Transit van, panel vans, and there were companies converting them, but they were having to buy a completely finished van and then remove the existing powertrain and kind of try and reverse engineer quite complicated OEM proprietary electronic systems and stuff like that to make it all work and not have a dashboard like a Christmas tree. And, it was really difficult. I was involved in some of those projects back in the time. So that more kind of open approach, the US has sort of always had with that more customized product. I can imagine that bringing some advantages. In the early days with the business, what were you thinking? But I'll change the intonation on that statement. A question: What were you thinking? Like, where did you think it would go? Were you sort of thinking that the delivery truck was your entry point, and then you were going to be, the next big truck manufacturer, or were you, a bit like Tesla did? They used the Roadster as their entry point, and then they were going to be the next big car brand. Were you kind of what was your original thinking behind where the business was going to go?
So actually, originally, I didn't want to be a car OEM at all. Originally, I described Motiv as like the Cummins for electric. I liked the idea of being a tier one supplier that could provide the core technology for multiple OEMs. I thought Cummins had a pretty great business model to do that around diesel engines. I looked at other companies like Allison with their transmissions, right, or Dana even with axles, right. And I thought these tier one suppliers, they can really focus their technology and innovation around a subsystem, and then you get a truck with an Allison transmission, and the resale value is higher than with another transmission, right? Like Allison actually commands that type of a value, and in doing that, they built a really valuable company, and they sell these big boxes of metal essentially, right? But they do it at a alarmingly good margins, right? 30% EBITDA margin. I mean, it's a great business. And Cummins is very solid as well. And Cummins over the years, I think, is still a very innovative company. But I think so that was the original vision, as like a tier one supplier. The advantage that like Allison and Cummins have that was tough in the electric vehicle space is there was some sort of kind of acknowledged defined definition of interfaces between the different parts. Like an engine mates to a transmission, an engine, sits in a chassis, and you kind of have any OEM, you could take an engineer from any one of the major truck OEMs and say, list the major parts of a truck, right? And any OEM would kind of give you the same list. I think if you were to do that exercise for an electric truck, your list wouldn't even look the same, right? Like the way that OEMs think about what they buy versus what they build, and even how they split up their sourcing. Is there a battery pack or is it battery modules that get integrated? Just like these interface questions. And so what that meant in practice, I think in our early conversations with OEMs in Motiv's early days, was we realized we'd just be doing a bunch of custom engineering, like across the board, for any OEM we wanted to work with. And that actually seems to have somewhat played out. I think Cummins and other companies like, Motiv in that tier one kind of supplier world do a lot of custom work for each OEM. And It's hard to kind of figure out, right? Like what voltage are we going to be running this system at, right? Like, I don't know, right? I think that's an interesting question to even answer. And probably some people will be ardently like telling you that the answer is very obvious, and other people will not, right? Like it's like, and even what that obvious answer is going to vary. So it creates an interesting environment, but so we realized, hey, like Motiv could do some of this custom engineering, but we didn't really have the DNA of a tier one. And so sometime around 2019, with like quality systems and the same standard products and trying to like put together programs for OEMs. So we actually kind of realized, hey, our real champions are fleets. Like in most cases, it's actually the end user fleet that is championing our technology. So let's build Motiv into being a electric truck OEM. Right. And so I brought in, the Motiv board, and I brought in a great leader, a Ford executive, and to lead Motiv through that transition. And we went from the Cummins for electric to a business model of more like, hey, we want to be like the Isuzu, or maybe Freightliner of electric, right? We liked the medium duty vehicle focus. I think it's a segment that's oft overlooked, and most medium duty vehicles are great candidates for electrification because they're used one shift every day and they never really drive that far mileage wise. Yeah. Right. And yet they still consume a ton of fuel. Right. So it's a good kind of mix there. But the volumes are lower. That's a challenge. But still you can build a good product, and even a couple fleets can create a reasonable volume. Yeah. So we built the company then in that direction. So we went from kind of being the Cummins of electric tier one to more like the Isuzu of electric OEM, and Motiv, continues to pursue that. And
actually, given where we sit today in 2025, I mean, I don't know, people, I've got podcasts out there that have been in, not quite 10 years, but a long time. And some of them have aged quite well, some not so, but someone might be listening to this podcast in 3 or 4 years' time. Motiv has actually managed to largely weather the storm in that space. There's a lot of startups in the electric truck space. Manufacturers come along with some interesting ideas about, new products and even in the medium duty space and work truck space. And unfortunately, over the last couple of years, it's been a tough market, I think would be a nice way of putting it. There's a lot of them fallen by the wayside and didn't manage to get through. What do you think it's been that the Motiv has that kind of made that difference in terms of it's survived where many others haven't?
I think capital efficiency is probably actually number one. Motiv's been around 16 years now. And we were lucky to have a really solid, committed investor base from the beginning. But we were also lucky to maybe not have raised a huge amount of money through like a SPAC or something else like that. We had looked at that at the time and just like decided, hey, this business and market isn't quite stable enough for like being public, when that happened a few years ago. And so I think having kind of more of a controlled growth, I think Motiv's attitude was always, let's take care of our customers first. So we're going to grow at the rate of growth allowed by our customers. And sometimes that's slower than we would like, but it's better to do that than like grow really fast and then not have the market, the industry behind us to support it. I think if anyone were to raise money and grow a company based on many of the openly available market projections of how fast the electric truck market would grow, they're either out of business or probably really hurting right now because those projections weren't right. And like, how did we get so far off? It's an interesting question, but but I think fundamentally it's a challenge to sell a product that's a lot more expensive up front, even if it does eventually save money, right? And I think getting those supply chains built takes a lot of time and a lot of money. And I think Motiv was always really good at kind of being kind of scrappy, or at least being capital efficient.
Yeah.
Right? Like we would prioritize on our customers, make sure we were taking care of them, and kind of let the rest sort itself out. And if that meant we had to delay some new generation technology or something like that, well, we just kind of go with the ebbs and flows of the market. I think if you raise a lot of money, you pretty much, no matter how much money, I guess what I've learned, no matter how much money you raise, you have to spend it in 18 months, right? Because it's like, in practice, that's the only way to have a chance at generating the types of returns that investors typically want, especially for like early venture companies. I think as you get like later stage of changes, but for like early venture stage companies, like whatever you raise, you've got to spend pretty quick. Or else you're never generate the returns. Like no one gives you money to sit on it in the venture world. So
it's not a 5 or 10 year plan.
Problem. Yeah, no. I mean, maybe eventually you can, you get to a point where you're a profitable ongoing company, which I would say hasn't happened too much in the electric truck space. And then maybe you raise lower risk capital that is a lot more patient. But I think until you get to profitability, you're probably raising capital that understands that it's a risk proposition. They're on a risk curve somewhere. And they're looking for big returns. And so you have to spend it. And, it's been battery companies, it's been electric truck companies, anybody in the space, right? If you raise a lot of money and you spend it all quickly, you have to spend it all quickly. And then you're at a position where, you might be at the edge of a cliff and that can be a problem. So.
And do you feel like now the market, so as we sit in 2025, I mean, I saw about 6 months ago, it's a really fascinating presentation. It was by a fleet who'd done, they'd done a lot of trials with different electric trucks, so things like the Tesla Semi and the Mercedes truck, so heavier duty than the Motiv products. But they were basically saying particularly the test they'd done with the Tesla had gone very, very well. The truck had excelled in operations that they hadn't expected it to. And basically, as soon as they could roll out enough of them, they were going to be saving a lot of money. And they felt that people who weren't doing that would be out of business pretty quickly. Now that kind of, I remember leaving that presentation thinking, wow, I wasn't expecting that. But it hasn't quite rolled out in the same sort of way. So I guess there's two questions. Like how close do you feel like we are now to that kind of that market developing and maturing in that way, and do you see the same thing now with the medium duty product, that it's at that tipping point of becoming essential to run these things, otherwise you won't be able to be competitive? Or do you think there's still a bit of an extra hard investment case to make?
It's a good question. There are a lot of interesting dynamics going around on like investment for medium duty electric and even heavy duty electric. I think so. I think a lot of it is still grant and incentive driven. I think everyone's taking a breather because it had become regulation driven, like you must buy these. And now that appears to have softened, I think everyone's taking a breath and maybe
coughing
stepping
a bit
back a
when
little
they're
bit.
breathing in those diesel fumes.
Yeah. Well, exactly. And and I think maybe missing the opportunity of like, hey, there are a lot of cases where electric trucks are just good business, good economics. I know Motiv still has some customers who understand that. But I think, like any investment with a payback period, it takes a little bit of understanding and a proof point, and get that capital allocated that way versus another way. And so I think for certain applications, electric is clearly a winner, and the payback period isn't all that long, and there's not a ton of risk in going to electric. There's still a lot of applications though where I think either the payback period is pretty long, or for whatever reason, when the fleets look at electric and trying to fit it with their particular use case and mission, they're still a little bit worried about the gaps that might exist in payload or range or infrastructure availability, or how many hours per day they have to charge, or whatever the case may be. And so those applications probably still need a little help to get going, or they'll take a little bit of time. So I think the market will grow probably slower than we would like. But I do think that for some applications, like Motiv definitely has some customers that are buying every year, and they're asking how many can you build, like those types of questions, because it's proven to them, right? And I think those types of fleets will become more common.
And that so you just briefly touched on there, because one thing, in your part of the world in California that was quite exciting was the California ports and what they were doing to kind of legislate to sort of strip a road to Cancer Alley to basically try and reduce exposure to emissions and whatnot on these really important trucking routes. But am I right in thinking that those, because we're going to outlaw the use of diesel engine vehicles in those applications entirely, and is that kind of gone away now, or have they just put it back a few years, or what's the situation around some of those really strong bits of legislation that were coming in?
So I think it's being reframed, as near as I can tell. The regulation and legislation federally and in California are being a little bit reframed. I think both federally and in California, everyone is still looking for ways to reduce carcinogens. If we can reduce exposure to cancer-causing substances, everybody wants to do that. And even looking at EPA and White House pushing back against California and some of CARB's regulations, they don't push back against that stuff. Like that's, everybody seems pretty united around that. I think where it is trickier is trying to associate a cost with just carbon dioxide or just carbon and looking at greenhouse gas. I think there are differing approaches, to say it lightly, on what we need to do there. And I think probably the way forward, in kind of this newly framed world, is more of a focus on can we make a better product? Can we make a product that's less carcinogenic? Right, and can we make it economical? And at the same time, let's reduce our dependence on carbon. That's a good thing generally, right? Or at least let's make our own energy. Let's have some energy independence here. And I think if for the right solutions, everybody's aligned. But I think if it's not going to kind of check all of those boxes, and it's going to cost a lot of money, and it's going to introduce other risks into the performance of a fleet's. These are tools. These trucks are all tools, right? They're tools to get a job done. Can't do the job, that's going to create problems, and people kind of are more recognizing of that, I think. What I learned interestingly on the cancer piece is, my new focus at Arcticar is on trailers, actually, and specifically refrigerated trailers. And there are cases where the refrigerated trailer, can produce 500 times as much carcinogens, cancer-causing particulate matter, as the truck that's pulling it, because we've regulated trucks and trucks with diesel engines down to very low emissions levels. But oftentimes the trailers aren't necessarily subject to those same regulations. And so, on that cancer corridor in Southern California, and at Hunts Point in New York City, right, where you've got these trailers, these refrigerated trailers, they can actually be the worst source of cancer, of carcinogens, of particulate matter in specifically.
Because actually, because we talked a lot about Motiv and all that, and how that came about and what you've done. But of course, you are now the founder and CEO of a new company called Arcticar. So, and you did a lovely little segue in. I'm going to reverse out a little bit and then let's go back in again. So, what was the thinking behind? You did all the hard work with Motiv, and it was just about stabilizing, and you thought, what, life's getting too easy. We're going to jump back in at the deep end again.
Oh, I don't know. I've never heard it put that way. But I do think there's a great team. Motiv has a great leadership team, and Motiv has announced the plan to acquire a Workhorse and merge those two companies, which I think is great. They have a complementary product portfolio.
Yeah.
With the Workhorse chassis and the Workhorse manufacturing plant pair nicely with some of the Motiv powertrain technology and the Motiv customer base, and so it's seems like a win-win there. I think that is pending shareholder approval, but it looks to me to be a good thing. And I think that really gave me, we have we have kind of a more than a critical mass of talent here between these companies and everybody that we need to kind of move it to the next level. And my work of like growing this through the early days, feels like maybe I can check that box. And so that kind of allowed me to depart from Motiv and gave me an opportunity to take a deep breath and I contemplated my life and waited a full 5 days before incorporating a new company. So
right.
I jumped right back in, but there's so many interesting problems to solve in this world and so much to do. And I relish the opportunity to get to hopefully be part of a new solution in a way where I can, help a adjacent but somewhat different market, address, energy independence and freedom from fossil fuel, kind of my career theme.
And this, so Arcticar, you're focused on electrifying refrigerated truck trailers. And it's one of those things that a lot of people might not really have thought about too much, where if we're moving things around, they have to be stored at a particular temperature. So foods, typically, lots of food gets moved around in refrigerated trailers. The trailer has an independent power system on it, a small engine. In the UK, we tend to call them donkey engines, but I don't know if you have the same expression. And it's a real basic little engine that thumps away and runs a refrigeration plant that sits on the front of the trailer and keeps the big box cold. But like you said just a moment ago, whereas the big engines, the emissions regulations that have come in were tiered to the engine power levels. So the most powerful engines had the most stringent emissions rules first. And it's taken a really long time to trickle down to things like those smaller engines driving those refrigeration plants. So big source of emissions, using a lot of fuel, running, when the truck's off in a rest stop, the refrigerated trailer engine is still running, pumping out lots of fun stuff, the drivers and everyone around is having to breathe in. So big industry. And someone told me this the other day, but I bet how many of those there are in the United States. There's a lot.
There are a whole lot. There are a surprisingly large number of those. It's your description was great. I might even steal the term donkey engine, but so I can quantify some of what you were talking about. So there are almost 500,000. It's like 450,000 of those refrigerated trailers in the U.S. And that's just refrigerated. That doesn't even count temperature controlled trailers, which are moving paint and candy bars and cosmetics, stuff like that, or even maybe moving liquids like beverages, that maybe you just don't want them to freeze and blow up cans and such like that. Right. And so there's a lot of these temperature controlled and refrigerated trailers. When you say they use a lot of diesel, that's probably an understatement as well. They'll burn a gallon an hour just maintaining temperature. Right, which is like somewhat similar to what a delivery van burns, a gallon an hour. Like it's pretty comparable. Over the course of a day, you can use as much fuel just keeping this trailer cool as like delivering a truckload of packages. And so it's really a lot of fuel use. And then I think you described it as like the engine thumping away. Well, I learned from a driver at a large food distributor, the largest food distributor actually. He said most of the veteran drivers are hard of hearing, because they're working all day around these diesel units. And if you've ever been around one that turns on or that's running, you can't even have a conversation. They're routinely above 85 decibels, which is, the acknowledged safety limit for long-term hearing loss. So you've got these units that are giving you cancer and hearing loss, burning a ton of fuel, right? And how do people feel about it? Well, I've spent the last few months talking with a lot of fleets, and the universal response is something along the lines of everybody hates refrigerated trailers, or refrigerated trailers are a necessary evil. People don't even like these products, right? I mean, and there's not much to like about them. They function well, right? And we all count on them because I want to get strawberries from the store and I would like them to not be rotting, please, right? So. I think we all like what they produce, but man, they are tough to be around.
Yeah, so it's a huge market with a pretty acute set of problems that you can solve, and you set up Arcticar to do this, and it's all about electrification? And are you making like complete reefer units, or are you supplying systems to other companies? Like what's the approach?
So what Arcticar builds is a electric version of what is sold today as like a diesel refrigeration system. So, today you buy a diesel refrigeration system, you bolt it to the front of the trailer, and you buy a fuel tank. It goes underneath the trailer, and then you fill it up with diesel and you go. What Arcticar sells is an all-electric refrigeration unit. You bolt it to the front of the trailer, same like cutout, same bolt pattern as the diesel one. It's just a lot lighter weight. And then a battery pack that you bolt under the trailer that is heavier than a diesel tank. However, when you net it out, the whole system's actually lighter. So you can actually move more payload on an Arcticar electric reefer trailer than a diesel reefer trailer. So fleets like hearing that. They're not used to someone pitching them something related to electric that's actually lighter than the diesel alternative. So I'm kind of thrilled with that too. I think after leaving my last company, I thought, gosh, I'd love to do something where I didn't have to compromise on the performance specs, right? Like I could actually just deliver a product that's all around better. And Arcticar is able to do that. And I think it's because battery pack technology is so much better than it was 5 years ago, and so much more available than it was a year ago. And so we've got available good batteries that we can drop into the system. And then building a ground up refrigeration unit is not trivial engineering, but it's also not rocket science. I've had a background doing this kind of stuff, and the supply chains exist now. So as you know, Ryan, you've been part of some of these. So so I think that's kind of the basic product is that it's just a drop-in replacement for the diesel system, and you can install it on the same trailers essentially. Now, do you retrofit or not? That really depends on how old your trailer is. But probably if you've got to buy some new refrigerated trailers, I would say please look at electric, because not only is it far quieter, right? It's lighter weight, and it's actually the same price. Like what I love about refrigerated trailers is we can sell an electric system at the same price, and we make money and the fleet makes money, right? It costs half as much to operate the thing, and you buy it for the same price. And so when people say, what's the payback period? It's not even a conversation, right? It's like 0 days. It's like from day one, it's the same price.
Wow. That sounds like a good business case. How does it, so, obviously a diesel product, you have a tank, you fill it with diesel. How does it work in terms of recharging the battery? Like where do you get the electrical power from? And is it something at the moment that's supported on every kind of mission profile for a reefer, or is it sort of particular fleets better able to deal with that than others?
I think there are always fleets that are going to recognize the benefits first. But what's nice about electric reefers, so as I started talking to fleets about this, I learned a few things. So for one, a single battery pack on a reefer, you're going to get 11 to 20 hours of cooling. And we have like commercial driving laws in the U.S. where someone driving a reefer trailer, right, is going to time out at most at 11 hours. And in other situations, they might even time out sooner. But at most, they're going to drive 11 hours. So you're not really going to run into a case where as you're driving down the road, you've run out of battery, right? Because you're going to have other problems first. Your driver's going to run out of time. You're going to have had to install that. But that doesn't mean that the place where your driver stops is necessarily going to have a place to plug in today. So I think, I'd like to see more infrastructure. We charge off of a few different standards. It can be an electric vehicle or electric truck charge station or a shore power plug. And shore power is a technology used frequently at warehouses. It's not a descriptive name, but it's used at warehouses to plug in trailers, anyway, diesel trailers that might have an electric motor in them for standby mode. So a lot of warehouses have shore power. And so what I found, though, what was interesting to me is when I talked to fleets, they said, hey, usually what happens is our reefers, they're sitting in a warehouse parking lot waiting to be unloaded. And we hire a diesel tanker truck to drive around that warehouse parking lot and refill all of the trailers, right? And like, how is the diesel driver going to refill the electric trailers?
Wow.
And to me, it was like such a great question, because I think it's a great example of like, you got to think a little bigger, like a little outside of the box when moving to electric. And it's the same question of like, well, my Tesla, I can't charge it at the gas station on the corner, right?
Yeah.
But it's like, yeah, but I can charge it when I'm at home, and it's actually, I don't have to stop at gas stations. And frankly, gas stations, like, who likes stopping at gas stations? It's never like, oh yay, I can't wait to stop at a gas station, right? So I think in the same way, these trailers, my response is, well, hey, like, maybe you don't have to hire that diesel tanker truck to drive around the parking lot anymore. Like, you probably need to invest in putting some plugs out in your parking lot, some shore power plugs, and drop them in from above if you don't want to trench through the concrete. Put in those plugs. It will be a capital investment, but your return on that investment is you're not hiring a diesel tanker truck anymore, right? Maybe initially you still need them for the diesel ones, but eventually, that's kind of a job that's probably going to go away, the diesel refueling guy, because you can plug these in, and then it's not like if the trailer sits there for over 4 days, now the diesel truck's got to come back a second time and put more diesel fuel into it, right? It's like, no, you park the trailer, you plug it in, leave it as long as you need, right? If it's there 2 weeks, that's fine, just leave it, right? And by the way, it's running at a fraction, less than half the operating cost there in the parking lot. So most fuel in these refrigerated trailers is consumed while the trailer is stationary.
Right.
And so what that means is when we're going electric, put in some shore power plugs, and you probably aren't even in a race to recharge it very quickly. You're probably sitting there and have plenty of time to recharge.
I was just going to ask about that, because obviously one of the issues with electric trucks, and particularly the big trucks, is the sort of megawatt standard charging and like huge power requirements. But I'm guessing the actual power requirements for this are much, much, much less than it would be for a truck. So you can use conventional kind of infrastructure architecture to recharge them when they're stationary.
Yeah, what's funny is these shore power plugs that fleets are putting in are grossly overpowered for the refrigeration need of the truck. And and that's because they want to use a synchronous 60 hertz motor, take no power electronics in the trailer, and they've got the 480 volt 50 amp power in the warehouse anyway. And so what happens is when you move to an electric refrigerated trailer, we've got the power electronics on board. We'll keep the reefer system running, and we'll recharge the battery, and we can do it fairly quickly, right? Like a shore power plug could recharge this trailer in 2 hours, right? And if you need faster, you can plug in an electric truck charger, a DC fast charger, and go faster. But usually you don't. Usually slower charging is going to be more cost effective, as we all know, in the truck space as well. And usually that trailer is stopped somewhere. And as you drive utilization up and you keep the trailer moving around, then maybe you do need a little higher charge rate. But the economics behind utilization tend to be really favorable. So as you're using the trailer more, probably the higher rate charging, is something that's going to be cost justified.
Okay, cool. I wonder, and I asked this just because I was interviewing them a couple of months ago, and a really interesting German company called Trailer Dynamics, who are building e-trailers. So their kind of business model is putting a small electric powertrain onto the semi-trailer or the articulated lorry trailer, and that can be used with an electric tractor unit or a diesel tractor unit, and it just a lot of flexibility around that. So there's a potential, or I guess there is the potential for things like that to provide power into a reefer system if needed in the future, if those things start to become more common.
Yeah, I think you can put solar on the top of the trailer to power the reefer system. I think there's a company in the UK doing that. Or you can drag the trailer and regenerate through the rear axle if you have an e-axle on the trailer. And there are some companies in the US doing these e-axles for trailers as well. One of them was doing it, ConMet. I don't think they're doing it anymore. But it's an interesting value proposition. To me, it's a lot like an electric truck. You now have a traction system. Like an electric truck, you have a few challenges there. I think generally it's not going to be the same price as the conventional equivalent, right? So you're probably going to be paying an incremental price for it, and that might be worth it over time. You probably will sacrifice a little payload as well, right? It's not going to be lighter; it's probably going to be heavier. and there are some applications where they're probably less payload sensitive, and so that can work. So, I think the future of like e-axles for trailers is an interesting one. I think the regulatory landscape there is pretty interesting too, because if you're going to be powering that axle, it's not really a trailer anymore, right? It's a self-propelled vehicle, and so that provides, you just have now a safety critical system. Which I've engineered safety critical systems before, and I think it's all of that can be done and can be done well. It just takes time and energy to do it right. So I think like self-powered trailers and e-axles for trailers will be an interesting emerging market. My guess is it might be a little bit slower to emerge because I think you've got those kind of challenges, some of the same that you see with electric trucks, but it doesn't mean there's not a ton of potential there to add value.
Yeah. Okay. Cool. And from your business perspective, are you very much just focused on the US market? US, Canada, or are you looking further afield? Is global domination on the cards, or what's the plans there?
What kind of a company would I be if I didn't have plans for global domination, right? Isn't that required? No, I mean, I think, look, I know the US and Canadian markets fairly well. I know the fleets. That's where we're starting. We're building products that are designed for those markets. I would love to be in a position in a few years where we've built such great relationships with fleets that are operating in the US and Canada that we start talking with them about their global operations and how we can help them in Europe and South America and Asia and be able to provide systems to do that, move beyond the trailer and maybe into some of the refrigerated trucks, into even refrigeration facilities, right? I think that the basic idea of like a variable frequency drive compressor and some DC tied energy storage is a neat value proposition when it comes to refrigeration systems, because you kind of have all the infrastructure that you need, and so adding DC tied storage and moving to variable frequency drive doesn't really add that much cost, and you potentially get performance gains in the one case, and then also the coordination between facility and fleet. Like there's a lot of energy systems you can optimize here down the road. Yeah.
I always wondered why, I mean, that sort of thing, I'm going off on a tangent here, but for something like a warehouse or a supermarket, for example, where they have, big cooling needs, but potentially they could do more of that using off-peak energy, or store the off-peak energy into batteries and use it through the day. So there's a real, with the amount of power that's consumed in refrigeration systems globally is absolutely enormous. But there's a huge potential to shift the demand for that around from the very second you're running it to actually, using a storage technology and getting the power at a different time and kind of balancing out that cooling load. There seems to be a lot of potential in that market space.
Absolutely. I mean, yeah, I think my eyes were open to this with the gateway drug of refrigerated trailers, but I think that ultimately, right, it's like, this is a fascinating space when you're looking at refrigeration energy consumption and the types of the loads that you see on this tend to not be that high of power relative to like other high peak loads. And so, maybe even as we see more automotive batteries ready for second life, like I love the idea of using second life traction batteries for, refrigeration loads generally, because it's a lot less demanding of a load. And so that's both fleet and facility side. So this is kind of speaks more towards Arcticar's like ultimate mission, which is far beyond just refrigerated trailers and into, energy refrigeration systems, right? Because I think that there's, as you point out, like there are a lot of new technologies that when applied, even as simple as variable frequency drives and second life batteries, right? We can extract just a ton of value for these fleets and their operations between, fleet and facility.
And it's a big, living where I do in the sort of north of England, it never gets too hot. It never really gets too cold. It's always a little bit in the middle, and then often rains. But living where you do, temperatures are a little bit more extreme, and there's very big differences. Nighttime temperature, daytime temperature, and actually that sort of cooling requirement shifts around. You need to cool most when the power is in most demand and at its most expensive, and just being able to kind of organize that better has massive potential benefits. So, mindful of the time, and just kind of bringing it to a bit of a close. Looking forwards for the next year or two, what are you most excited about? What have you got that's coming that's exciting you most at the moment?
Oh man, well, I think it's been fun getting back into an early stage company building. Right, I get to do a little bit of everything, but I think I'm kind of most excited to get the technology on the road with some fleets. I think having electric refrigeration available is going to be a big win for the industry, and especially for the drivers that work around these systems. And so I'm pretty excited about that. I think it's going to be a good next year or two, kind of doing some company building here. So yeah, should be fun.
Brilliant. And I wish you all the success, and I think you've got a great potential here. So sounds really, really exciting, and I will keep a very close eye on what you're doing. But best of luck. Thank you so much for taking the time out today, Jim.